Okay, so let's just jump right in. You know, we tend to think of our world, our cities, our homes, our offices as solid things, static, permanent. But what if the key to a smarter, more efficient future isn't solid at all? What if it's fluid? Today, we're going to explore how this one idea, the concept of fluidity, is completely reshaping the world we build around us, from the tiniest micro scale all the way up to the monumental. I mean, really think about it for a second. We live in this incredibly dynamic, constantly changing world, right? Sun moves, seasons change. Yet, buildings we spend almost all of our lives in are these rigid, unmoving boxes. They're basically in a constant battle with the environment instead of adapting to it. And that leads to a huge problem. And the scale of that problem is just staggering. Researchers at the University of Toronto found that our buildings gobble up a massive amount of energy. We're talking more than the entire manufacturing sector and all of transportation combined. So yeah, it's pretty clear that making our buildings smarter isn't just some nice-to-have idea. It's an absolute necessity. So where do we even start to look for a solution to a problem that big? Well, funny enough, we can look at the sea. The first really cool innovation we're going to look at is a liquid window that was directly inspired by the amazing color-shifting skin of the squid. This quote from the lead researcher, Raphael Kay, just nails the whole goal. See, it's not just about blocking the sun. It's about being strategic. It's about controlling the amount of energy, the type of it, like separating visible light and that invisible heat you feel, and even the direction it's going. If your window can do all that, your building's heating and cooling systems barely have to break a sweat. And this chart lays it all out. On the one hand, you've got current smart tech, which is basically a fancy on-off switch. It blocks all the light, or it lets it all in. That's it. But then you look at what these liquid windows can do. We're talking nuanced, dynamic control. Imagine on a hot day, telling your window, hey, let the light in, keep all the heat out. Or on a chilly day, you know what? Let them both in. That's the kind of power we're talking about here. Get this. The results are incredible. Based on their detailed computer models, just a single layer of this liquid window tech slash a building's energy use by about 25% a year. Now, add a second layer to also control visible light, you jump to around 50% savings. That is a total game changer. So, we've seen what this amazing window can do. Now, let's zoom in. I mean, way in. We're going to go from the scale of a huge building facade all the way down to the microscopic level to see the wild technology that actually makes this whole thing possible. And that really is the million-dollar question, isn't it? It sounds like something straight out of science fiction, telling tiny little streams of liquid exactly what to do. Well, the answer lies in a field of science that's powerful, but is small. That science is called microfluidics. We're talking about channels so incredibly small you could a bunch of them across the width of a single human hair. By controlling fluids at this tiny scale, engineers can create something they call a lab chip, an entire complex system shrunk down onto a single tiny platform. In this case, that platform is our window pane. It's wild is that the whole process is a lot like computer programming. Researchers can literally write fluidic code. So step one, they write the instructions, something like mix these pigments to block infrared heat. Step two, they compile that instruction for the chip. And then step three, the chip just does it. Precisely pumping and mixing the fluids to get the exact optical effect they want. It's literally programming with liquid instead of electrons.
Okay, so hang on, because we just went super deep into the microscale. Now let's pull the camera all the way back out, going from a tiny chip inside a window pane all the way up to the shape of a towering skyscraper. Because the same core idea, understanding and controlling fluids, applies at every single scale.
And here's the big leap. The liquid inside that window is a fluid, sure. But you know what else is a fluid? Air. Wind that flows around a building every single day. So what if we started designing our buildings not as solid blocks that just fight the wind, but as elegant structures that are actually shaped by the wind? Engineering idea behind this is called fluid structure interaction, or FSI for short. The best way to think about it is like a two-way conversation. Wind pushes on the building, and the building's shape pushes back, changes how the wind flows. New design methods finally letting architects treat this whole interaction not as a problem to be solved, but as a creative tool. Now, this diagram might little intense. The core idea is absolutely revolutionary. Traditionally, an architect would design a building and then test it against the wind. This new process does both at the exact same time. It's a constant feedback loop. The computer models the wind, adjusts the building's shape to be a little more aerodynamic, and models the wind on the new shape over and over and over and over. Final design literally evolves, sculpted by this virtual wind.
Wow, the results just speak for themselves. On the left, you've got a design that was only optimized for strength. It's jagged, kind of blocky, fighting the airflow. Then you look at the design on the right, the one that evolved using this fluid structure interaction. It's more organic, it's elegant, because it was sculpted to work with the flow of air, not against it.
And it's not just about looking cool either. A beautiful, elegant form on the right is also a much better performing structure. It actually experiences less internal stress from the wind and improves the environment around it by letting air circulate more freely, which is super important in dense cities. So let's just recap for a second. We've journeyed from a squid-inspired window all the way to a wind-sculpted skyscraper. We started by putting fluid inside our buildings. We ended up shaping our buildings with the fluids that are all around them. All of this points to a radical and really exciting new philosophy for the future of architecture. This really is a whole new paradigm in design. It's about finding that perfect balance between a building's inner strength and its outer environment. It gives architects so much more freedom to create these incredible, innovative forms. You're not just optimizing one building, you can optimize how entire clusters of buildings interact with their surroundings. You're harmonizing all these complex forces that we used to think were in conflict. There's actually a name for this bigger idea that's starting to emerge: fluid architecture. It's a whole philosophy that sees buildings not as these static objects, but as dynamic systems, as spaces of flow that are flexible, adaptable, and deeply, truly connected to the world around them. From windows that manage sunlight like a living skin, to towers that are literally shaped by the air itself. It feels like we're moving away from a world of rigid, static things. And that leaves us with one final, pretty fascinating question to think about. What if our buildings could finally be as alive and as beautifully responsive as the world they inhabit?